Hey guys, today we're going to talk about how to take a polar coordinate and convert it into the normal rectangular XY coordinates that we're used to. So it's actually pretty simple. We know that polar coordinates are given by this right here, r comma theta. So we're going to use those two values to convert it to XY. Our x value is going to be r times the cosine of theta, and y is going to be r times the sine of theta. Now, because most of the time we're given our angle in radians, we are going to need our unit circle for this, so I already have one pulled up. Okay, so let's look at the first example. It says convert each pair of polar coordinates to rectangular coordinates, round to the nearest hundredth if necessary. Okay, so I have 2 comma 5 pi over 3. That 2 is r, and the 5 pi over 3 is our theta. So if I follow the equations from above, x is equal to 2 times the cosine of 5 pi over 3. Y is equal, so almost the same, but this time we're going to use sine. So see that? Cosine of 5 pi over 3, sine of 5 pi over 3. There's an actual value for those, so I'm going to go to my unit circle. I have one pulled up over here to the side. And let's look for 5 pi over 3. That is right here. There's my angle. So cosine is 1/2 and sine is negative square root of 3 over 2. So I'm going to plug those in. Okay, so cosine, this will be 2 times 1/2. That's times. Which 2 times 1/2 just gives me 1. Okay, over here for sine, we said that that was negative square root of 3 over 2. For this one, the 2's just cancel out, so y is equal to the negative square root of 3. So my xy coordinate, my rectangular coordinate to match with that point, is 1 comma negative square roots of 3. Okay, let's do another one. So I'm only going to do the odd ones here, so let's go right below. We have negative 1/4 and negative pi over 2. This first is our r. This is theta. So following the equations, x is equal to negative 1/4 times the cosine of negative pi over 2. Y is going to be equal to negative 1/4 times the sine of negative pi over 2. So negative pi over 2 is the angle that we need to find the value for. We need both cosine and sine. So I'm going to go back to my unit circle. We run into a little bit of a problem because pi over 2 is right here, but that's positive. I need it to be negative. So starting from the 0, I went to the next axis to find that. So I'm going to go in the negative direction and go down here. So we're going to use these values. We're going to use this. So here's my cosine is 0 and sine is negative 1. Okay, so back here, I still have my negative 1/4, but I'm going to multiply that by 0 because we're replacing. So anything times 0 is just 0. Okay, and then for y, we're replacing sine of negative pi over 2 with a negative 1. Negative times a negative is going to turn that into a positive 1/4. So my rectangular coordinate that matches with that polar coordinate is 0 comma 1/4. Okay, and then let's do one more. So we have the polar coordinate, 9 comma 140 degrees. So this one's going to be a little different. Obviously because it's in degrees instead of radians, but we're going to work on it pretty much exactly the same. So r in theta, x is equal to 9 times cosine of theta, which was 140. Y is equal to 9 times sine of 140. So 9 times, well, I don't know what the cosine of 140 is, so let's look at our unit circle. We run into a problem because here's 135 and then here's 150. 140 would have been somewhere in the middle. So it's not one of those special angles that's on here, so I cannot get a number from here. So in this case, you're kind of forced to use your calculator. And so that's why they told us we can use decimals here. I don't have Desmos pulled up, but I do have it here on the side, so I'm going to type this in. So for cosine of 140, I'm going to use 4 decimal places because I want this to be as accurate as I can get it. Negative 0.7660. So when I multiply that by 9, that's negative 6.89. Okay, now we're going to do the same thing with the y. I already know I'm going to have to type that into the calculator, so let me see. So that is positive 0.6428. And then when I multiply by 9, that is 5.79. Okay, so those are my x and y coordinates to go with that polar coordinate. So negative 6.89, comma, 5.79. So not too bad. You just follow the formula. R cosine theta, y is r sine theta. Okay, but this is when they give you a polar coordinate and you're going to rectangular. What if I want to go the opposite direction? So here, if they give you x, y, so what we're normally used to seeing, and they tell you they want you to convert it into polar, you need to know how to find r and how to find theta. R is going to be equal to the square root of x squared plus y squared. Theta, so because it is an angle, we're going to have to use some trig here. Theta is going to be equal to the tan inverse of y over x. Okay, so just like before, I'm not going to do all the examples shown. I'm only going to do the odd ones. So let's start here. Oh, one important thing to remember. So recall, polar coordinates are not unique. So there's a chance that I'm going to find one and then you do it yourself and it might be a little bit different. You just have to make sure that they're equivalent. Okay, so this first one, 2 comma 2 square roots of 3. So remember this is xy. So this is our x value, this is our y value. Notice how they're both positive numbers, positive, positive. So that tells me that I'm in quadrant 1. So that'll help me narrow down some of my numbers. So let's start with r. So my formula up above is I need to do square root of x squared, so 2 squared, plus y squared, so 2 square root of 3 squared. So this would turn into, this is 4 plus 4 times 3 is 12. So that's square root of 16, which is just 4. So r equals 4. Okay, so now we need to go and we need to find theta. So back here, theta is tan inverse of y divided by x. So 2 square root of 3 divided by 2. Well, right here, the 2's are going to cancel out. So this really should be tan inverse of just the square root of 3. So you can actually use your unit circle for this. So we're going to work backwards. So let's look. Now remember, we are in quadrant 1. Like, that's why it was important that we looked at that earlier. So I'm only going to look at quadrant 1 of the unit circle. And let's look at our tan values. There's my square root of 3. That's what I needed. So what angle is that? It's this angle, pi over 3. So that's actually my answer. Theta is going to equal pi over 3. Okay, and then now that I have them both, r and theta, I can say that my polar coordinate is 4 comma pi over 3. 4 is the radius, pi over 3 is the angle. All right, so let's look at another one. So we have negative square root of 3 over 2, that's our x, and negative 1/2, that's our y. So in this case, x is negative, y is negative. If you can picture the quadrants in your head, this would be quadrant 3. Okay, so let's start by finding r. So square root of both of these values squared. So negative square root of 3 over 2 squared plus negative 1/2 squared. This would be 3/4 plus 1/4, and they're still in the square root. That equals 1, so square root of 1 is just 1. Okay, so radius is 1. Cool. Now we need to find our theta. So we do tan inverse of y over x. So y was negative 1/2. X is negative square root of 3 over 2. So it's kind of a giant fraction. We want to simplify all of that as much as we can. Good thing is that they're both negative, so automatically means it's going to be positive. They both have the same denominator, that over 2. So honestly, we could just get rid of that. So now I'm up to this tan inverse of 1 over square root of 3. But we kind of have a problem still because we're not allowed to have radicals at the bottom. So to fix that, let's multiply by square root of 3 on top and bottom. So this really should be tan inverse of square root of 3 over regular 3. Okay, so we're going to do what we did before. We already said we're in quadrant 3, so I'm going to look at quadrant 3 of a unit circle, and let's look to see when the tangent value is square root of 3 over 3. Okay, so quadrant 3 down here. Look at your tangent values, and right here, square root of 3 over 3. So that goes with 7 pi over 6. So that's our answer, that's our angle. So our coordinate, our polar coordinate is 1 comma 7 pi over 6. Okay, that's actually all that I'm going to show you guys for today. So just get comfortable with switching back and forth between polar and rectangular. They each have their own little formulas. So you're always going to have your notes. You'll be able to see that. And just be sure that you have a unit circle handy for this assignment.